Hello everyone, myself Forum Makwana, Assistant Professor of EC Department at LJ Institute of Engineering and Technology. Welcome to the session of Digital System Design. We have started unit number 3, that is sequential logic circuit design. We have studied in the last session what we mean by characteristic equation, characteristic table, excitation table. Okay, and what is easy to apply. In today's session, we are going to study the T flip-flop with its excitation table, how to convert from one flip-flop to another flip-flop, and its excitation table, and the basic introduction of the counter. Now, we know that the T flip-flop means what? At the rising edge of the clock, and if T is equals to 0, there will be no change in the output. But if the T is equals to 1, my output will going to be toggle. That means it will continue to change its state from 0 to 1, 1 to 0, likewise. So T has only one input and the two outputs. Okay? This is the logical diagram that we have already studied in the last sessions. Alright? So before starting the excitation table of T flip-flop, I just need to revise the excitation table of the SL that we have studied in the last session. As my SL flip-flop is the positive edge trigger, so for the rising edge of the clock and the state of the input, we are able to derive its output. Okay, that is my truth table of SL flip-flop. So from this truth table, we are going to derive the excitation table. So excitation table we are going to be obtained by the present state and the next state, and we are going to derive the inputs from it. Okay. From the output, we are going to derive the inputs. So this one is called the output driven. Alright. See, two inputs. Present state, next state. Q and Q of n plus 1. Two variables. Four combinations are there. 0, 0, 0, 1, 1, 0, and 1, 1. So for S and R, 0 cross. For Qn plus 1 is equals to 0, 0. Alright? For Q is equals to 0 and Q of n plus 1 is equals to 1. That means I can say that my flip-flop will be set. So S is equals to 1, R is equals to 0. Alright? Similarly, it will be like S is equals to 0, R is equals to 1, and cross that represents the state. It can have any variable. It can be a 0 or 1. Right? That's a basic like cross and 0. Right? This is the excitation table of SR that we have already discussed in the last session. So now we are going to derive the excitation table for the JK flip-flop. What is the need of this writing of this excitation table? The reason is it is used for conversion of one flip-flop to another. Right? So for that we need the truth table for each and every flip-flop. Over here, we are going to derive the excitation table for JK flip-flop. So we must have the truth table of JK flip-flop, right? Present state and the next state, we are going to derive its input. Okay? Procedure is same 0, 0, 0, 1, 1, 0, and 1, 1. Now, if my present state is 0 and next state is 0 as well, so I can say that my value of J is 0. But the value of K would be a 1 or a 0. That's why cross is there. For 0, 1. My present state is 0, but next state is 1. That's why I can say that my flip-flop can be set. Okay? So the value of J would be 1. But the K can be either 1 or 0. Why? For 1 1 output would be lower, and for 1 0 output can be set. For present state, q is equals to 1, next it is equals to 0. So value of Jn cross and 1. Cross means 0 or 1. Okay. And my present state and next state are not going to be changed. That's why Jn is equals to cross and Kn is equals to 0. Right? Now for the D flip flop. We know it's truth table. If D is equals to 0, Q is equals to 0. If D is equals to 1, Q will be 1. Simple. Okay. So whatever may be the state of the next state will be my input. See. Present state 0, next state 0. That means input 0. Next state is 1, input will be 1. Next state is 0, input will be 0. Okay. So it is the same as the next state. For the T flip flop, we know that if T is equals to 0, there is no change. T is equals to 1, output will be toggle. Alright? The excitation table for the present state and next state, if both are equal, that means input will be 0 because there is no change. If there is change in toggle, output is changed from 0 to 1, that means T would be 1. Over here T would be 1. If there is no change, that means T would be 0. Now we are going to focus how to convert the one flip flop into the another flip flop. So D to SR. Right? See, we need the truth table for D as well as the truth excitation table for SR. So whatever may be the flip flop is present, I need its truth table. And in which flip flop I need to convert? SR. So for that excitation table I require. Okay. So from this truth table of D flip flop and the excitation table of SR flip flop, I need its conversion table. From which flip flop to which flip flop I want the conversion. Over here D is there, so write in the first column the value of D 0, 0.9. As it is a conversion table, I require value of Q and Qn plus 1. That means 0, 0, 0, 1, 1, 0 and 1, 1. From this output, we are going to derive its value of input S and R. Alright? So, for Q and Qn plus 1 is equals to 0. That means either my flip flop would be reset or it can have a value R is equals to 0. S must be a 0. So 0 was. My output is going to be changed. Earlier it was 1, now it is 0. So I can say that it would be a reset and value of S will be 0. As my output is next step is set, that means flip flop is set, so S is equals to 1, R is equals to 0. The last case, there would be a no change, or I can say my flip flop will be a set. Okay, so S is equals to cross, it can have two values, whether 0 or 1, and R is having a 0. Right? So I am going to write the K map for this. So what you require? Value of D and the Qn. So it is a two variable K map is there. So write accordingly for S and R. You are able to identify that S is equals to D, R is equals to D dash. So if we want to convert that in the form of circuit, It is like it is like a SR flip flop, and we need to convert this SR from D flip flop. Like connect the S directly and the R with the NOT gate. Okay. Now T flip flop to JK flip flop. So it is a truth table for T flip flop. We know that the exciting table that we have already discussed for the JK flip flop. So the procedure will remain the same. T flip flop is available. So T is as it is. Q and Q n plus 1 you need to write like same as earlier. For J and K, write this as it is. 0 cross, cross 0, 1 cross and cross 1 from this excitation. And convert it into the simplification of K. You are able to identify J is equals to T, K is equals to T. That means if I want to convert T flip flop to JK, I can say that J and K both are shorted, which is having only single letter T. The flip flop excitation tables are like this that we have derived. This is for SR, this is for T, JK and D. We have already derived. Now, what is counter? So the counters are specific type of sequential circuit in which the output value is going to be increased one by one for each clock cycle. It can be increase or decrease. So increase means up counter, decrease means down counter. Okay. So after the largest value, it will wrap around back to 0. Right? Using 2 bits, we are able to get the counter like this. First step 0, 1, 2 and 3. After 3, counter is going to be reset. Okay, so it will be in the continuous state 0, 1, 2, 3, 0, 1, 2, 3 like this. Okay, so if I want to represent the states for 2 bits 0, 0, 0, 1, 1, 0, 1. For 0, the next state is 0, 1. Next state is 1, 0. Next state is 1, 1. Next state is 0, 0. It is formed in the table. So, what are different types of counter? There are 2 principal categories. It can be a ripple or it means asynchronous or it can be synchronous. The first flip flop is going to be clocked by the external clock pulse and remaining are getting the clock signal from the output of the first one. Okay? And this is our previous one. Synchronous means all the memory elements, all flip flops are getting the clock pulse at the same time. Alright, so we are going to study in depth the different types of synchronous or the asynchronous counter into the next session. First, if you have any doubt up to this regarding the excitation table, characteristic table, the conversion from one to another flip flop, you can ask me at any time of time. We will be ready. Till then, thank you for your attention.